Hey guys, hello everyone. Welcome to this module 1 of Advanced Java Programming. So let's discuss what we have in module 1. In this module, we will be dealing about enumerations, autoboxing and annotations, starting with what is an enumeration in Java. So enumeration, or I should say enum, is a special class that represents a group of constants. Constants in the sense unchangeable variables which are final. Okay, so first let's look after the definition. We have as an enumeration is a data type that consists of a fixed set of constants. It can represent a days of week, directions. It has been available since JDK 1.5. So enumeration is nothing but data type itself, a data type which stores a fixed set of constants. The fixed set of constants can be anything. Here, for example, they have taken the directions and the days of a week. So what are the characteristics? Characteristics of enumeration are they are public, static and final by default. Next we have is enumeration can have constructors, methods and instance variables, but you do not instantiate an enum using a new. That means in enum we are not instantiating it using this new operator, and also enumerations are declared similarly to primitive variables. So let's look after the syntax. Syntax we have is enum subject, then we have Java CPP CDBMS. These are nothing but the fixed set of constants. Okay, fixed set of constants. So what is this usage? We are declaring an enum variable that is by the name of subject. Then we are assigning a value that is subject.java cpp c and dbms, and we are comparing the values using this equal to operator. Like if subject equal to Java, then we have to perform some kind of operation. Now let's look into the example. First example we have is a simple enumeration. Simple enumeration, what we're doing is we are taking all the weekdays: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now what we are doing is next we are now in the main function weekdays, wk nothing but a variable itself which will store the value, which will store a particular constant of a enumeration which we have declared. Then weekdays dot sun is nothing but you have to check whether in the enum constant where is sun. So system out the println today is plus wk. Here wk will be assigned with sun, so output is today is sun Sunday, like that way. Moving forward, that was a basic example of an enumeration. Now what if we have a switch statement? So in switch statement what we are doing is we have an enumeration of restaurants. We have Domino's, KFC, Pizza Hut, Panino's and Burger King. So let's look after this look after this main function. What we are doing is here again we are creating a variable called r for dealing with the enumeration and storing the constant values in them. Then restaurant.Panino's, like here we have fixed like in that particular r variable we are putting the constant value as Panino's only. Again we have a switch case of Domino. If it is Domino's, then I am Domino's. If it is KFC, I am KFC. If it is a Pizza Hut, I am Pizza Hut. If it's Panino's, then it's a Panino's. If a Burger King, then it's a Burger King. Now since I have already declared restaurants dot Panino's, that means this r value, this r variable is storing the enumeration constant as Panino's. We have to give the output as I am Panino's. Okay, let's move forward. We have something known as values and values of method. Value method, what we'll do is it is added by the Java compiler to add an enum. The main function is to return an array containing all the values of the enum. Okay, so it will return the array which contains all the value of the particular enum function. The syntax is public static enum type values. Now what is this value of method? Value of method will returns the enumeration constant whose value is equal to the string as passed as an argument. Okay, so what is the general form of that? Public static enum type value of, just value of method we have to use instead of value. They have to pass the string as well. Now let's deal with this program. Now we can see, like using values and values of method, we have taken enumeration of restaurants, same thing, Domino's, KFC, Pizza Hut, Panino's and Burger King. Now what we have done, first we have taken this all constants of enum type restaurants are, then we have just created an array. This array, what we'll do is it will returns an array of constants of that particular of type of restaurant. That means it will return the array of all the restaurant names which I have stored. That means Domino's, KFC, Pizza Hut and Paninos. Next, what we are doing is we are just taking a for loop for each type, and then you are just printing the each and every constant that is for restaurants of a colon r array. We are just looping throughout the array and printing all the elements which are present inside the array. Then we are checking if the value of is if it is Domino's, then you have to print I am Domino's. So you can, as I said in the output, what we have to do is all the enum type restaurants, that means all the constants we have printed, that is Domino's, KFC, Pizza Hut, Paninos and Burger King. Followed by that we had a print function there, that is I am space Domino's, so it has printed I am Domino's. Now next we have is what points we should remember about when it comes about enumeration. We have to mention all these points when the question comes define enumerations as well. So this we have to mention. Enumerations are of class type and all have the capabilities of a Java class. So they basically are of class type only. They can have constructors, instance variables, method and implement interfaces as well. Enumerations are not instantiated using the new keyword because normally for instantiation we often use a new operator, but in case of enumerations we don't use a new operator. Now all these enumerations by default are present in java.lang.enum class. Now all the enum may implement multiple interfaces, but it cannot extend any class because it internally extends the enum class. That means enum can only extend an enum class only, but it cannot extend any other classes, and also it can implement multiple interfaces as well. Next we have is Java enumeration as a class type. What happens here when in class type, each enum constant is an object of its enumeration type. That means whatever constants are present in my enumeration, each of them will be treated as an individual object. Next, constructors for an enum are called when such constant is created. Next, each constant has its own copy of its instance variables defined by the enum. Let's look into this example. What we have done is, you can see in this provided code snippet, this apple2 is nothing but an enum in Java that represents different types of constant, that is Jonathan of 10, Golden Del 9, Red Del 12, Winesap and Cortland. Now what we have done is, next we have taken a variable that is known as price. It's nothing but an instance variable only which is holding the price of each and every constant. Then we have a constructor. This constructor, this apple2 of int p initializes the mainly price of each and every constant. Then we have a method, that is int get price method. What this get price method is doing is it will return the price of each and every apple. I mean each and every apple constants, whatever it is given. Okay. Now next is the main function display price of Winesap. What it will do is apple2.winesap.get price. What it will do, it will help me in outputting the particular price which is of Winesap. The same goes for the Golden Del. The same goes for the other prices as well, like display all apples and prices. So what we have done is we have taken a for loop. This for loop, what will do, it will iterate all over the enum constants using this apple2.values method, and for each apple type it prints the name and price. Okay, like Winesap costs 15. This 15 is nothing, we have taken it from here, you can see. Similarly for 10, Jonathan, Golden Del, Red Del, Winesap and Cortland. Now enumerations inherit enum. Inheritance. First, we already know what is an inheritance. All enumerations inherit from the java.lang.enum package. Next, methods provided by this class include ordinal method, compared to method and equal to method. So guys, one thing you remember, whenever what it asks like what all methods are present in the enumeration, we have to write it's ordinal, compared to and equals. What is the ordinal method? Ordinal method will return the ordinal value of an invoking constant. What is the general form? Final int ordinal. Ordinal value start at 0. Then we have a compared to. Compared to will compare the ordinal value of two constant. Again the same format, final int compared to enum type e. It will return a negative value 0 or a positive value depending upon the comparison. That means in ordinal method always the value will start at 0, whereas in compared to method we can see it will return a negative value or a 0 or a positive value depending upon what type of comparison I am doing. Next, we have the program for using the compare to method and all. So we can see here what we have done is, again, enum 5 is defined to represent the various type of constants. Okay, so the enum ordinal class demonstrate how to use some of the common enum methods. So let's see them. First, we can see that we have declared 5 constants. That is nothing but Jonathan, Golden Dell, Red Dell, Winesap, and Cortland. Now let's look into the main function. In the main function, what we have done is ordinal method. So the first ordinal method, what it is doing is it will return the index of the enum constant in its enum declaration, where the first constant of it is 0. Okay, that means what it will do, like we have a for loop, like for apple 5a colon apple dot 5 values. So it returns the you can see the position of the enum constant in the enum declaration, where the first constant are always indexed as 0. Okay, so next, if we see, that is apple, next we has compared to method. Or compared to method, what we'll do is it compares the ordinal value of the current enum constant with the another constant. So it returns a negative number if the current constant becomes before the other 0 if they are same, and a positive number if it comes after. Okay, so that means same thing we have done. If it's less than 0, that means it becomes negative. Greater than 0, it's positive, and 0 if it is equal. Then again we are checking if both are equal or not. ap dot equals ap2, then it's error. ap dot equals ap3, that means it will be equal. So next, let's see the output. Here we have all the apple constants and their values. Jonathan 0, that means first you can see it was indexed at 0 only. So it started from 0, followed by, you can see all the indexes were print: Golden Dell, Red Dell, Winesap, and Cortland. And next we have just checked whether what comes after the other, and we were checking whether both of them were equal or not. Next, we both the enumeration constants were equal or not. Next we have is Java type wrappers. Java type wrappers, what it will do, it will encapsulate primitive types and within objects. This is useful for scenarios where you need to use primitive types as objects, such as when working with Java collections or other object-oriented frameworks. So Java type wrappers will help you to encapsulate the primitive types within the object, and also it is needed when we are working with the Java collections and with the object-oriented frameworks. Let's look into this in detail. Primitive types and performance. So Java uses primitive type, that is int, double, and float for performance reasons. For doing normal arithmetical operation, normal programming practices, we are using this primitive types and performance. Then need for object representation, like many data structures and APIs in Java requires objects, not primitives. Hence type wrappers are very much necessary. Okay, what is a type wrapper? Type wrappers, Java provides wrapper classes for each primitive type, allowing them to be treated as objects. That means whatever primitive type we have created using Java, we can treat them as objects. First, we wrapper class for character. Purpose is encapsulate the primitive type of char. That means character bracket char ch. This is the constructor for that. For boolean, it encapsulates the primitive type boolean. That means nothing but we're encapsulating it into its primitive type. Then constructor, boolean, bool value. Similarly, for the same numerical type, byte will be byte, short, integer, long, float, and float. Double will be double. Next, we have something known as boxing and unboxing. So boxing and unboxing mainly deals with the conversion between the primitive types and their corresponding wrapper classes. This is particularly useful for situations where you need to work with objects instead of primitive types. So boxing and unboxing are used only when you want to work with objects but not with the primitive types, and also it helps in the conversion between primitive type and their corresponding wrapper class. So what happens is, boxing, you are encapsulating a primitive value within an object. Unboxing, you are extracting the primitive value from its wrapper object. Encapsulation just nothing but you are just joining, or you can say all clubbing a particular primitive value within an object. And unboxing is nothing but you are extracting or taking out a primitive value from its wrapper object. Okay, let's look into this example. Class wrap integer IOP new integer of 100. This is nothing known as boxing. Why? Because you are encapsulating a particular primitive value inside it, okay, within an object. Now next what you are doing is int I equal to IOP.int value. This IOP.int value method, what it will do is it will extract the primitive value which is present, and it will extract it from its particular wrapper object. Now if you try to print both of them, this I is also 100 because here you have unboxed it, you have extracted the primitive type, and here you have already encapsulated it. So the output becomes 100 and 100. So one thing guys, always remember, in boxing you are encapsulating, and in unboxing you are extracting. Okay, what is the explanation of the code? Integer IOP equal to new integer of 100. It encapsulates the primitive value 100 into the integer object. Next we have int I equal to IOP.int value. It extracts the primitive value from integer object. That means boxing is nothing but encapsulating, unboxing is nothing but extracting. Okay, very simple to remember. And guys, one thing, whenever this kind of question comes like boxing and unboxing, or it's like enumeration programs or the types, please make a habit from now itself. Whether the question comes, you have to write the syntax with the example program along with the output. These three things are very much mandatory when it comes for the VTU exam. Okay, and moving forward, next we have is autoboxing and unboxing. What is autoboxing now? The Java 5 version introduced autoboxing and auto unboxing, simplifying the process by allowing automatic conversion between primitive and the corresponding wrapper objects. That means nothing but automatic conversion between the primitive and the wrapper object itself. Let's look into an example. Integer IOP equal to 100. That means directly you are doing this is nothing but autoboxing, automatic conversion. Next, int I equal to IOP, nothing but we are auto unboxing it. Fine. Next, we are just printing both the values I plus space of IOP displays 100 comma 100. Next, again this is for integer we have done. You can do it the same for characters as well. Character COP equal to A, character CH is equal to COP. That means previous example was auto boxing, this is auto unboxing. Unboxing is nothing but again you are just taking the object back, you are just extracting it and you are storing it in one more variable. Then system.out.println again displays this A and A. Fine, the output is 100 100 for integer, for character is A comma A. Then what about that? What about autoboxing and unboxing and expression? In expression, how you do it? When talking about the wrapper objects and expressions, Java automatically unboxes and reboxes the values as needed. That means by default Java can do the unboxing and reboxing whenever it's required. Let's look at the example. Integer IOP is 100. That is nothing but autoboxing we are doing. Plus IOP, we're just incrementing by unboxing, first unboxing it, then incrementing and again reboxing it back again. Next, we're again printing the value. It's nothing but 101. This is again post increment. You guys already know this. Then what is the benefit now? What is my benefit of doing autoboxing and unboxing? Why I'm doing all these things? First is interchangeability. It allows primitive types and wrapper class objects to be used interchangeably. Next is no explicit casting. Eliminates the need of explicit typecasting, no need of explicit conversion. Also next we have is error prevention. Helps to prevent errors that occur during the manual boxing and unboxing. That means sometimes when you are doing the boxing and unboxing manually, you may encounter some or the other type of error, but when you are doing this auto boxing and auto unboxing, this kind of errors can be prevented. Next we have is the mixing different types of numeric objects. Autoboxing and unboxing allows mixing different types of numeric objects in expression. That means using autoboxing and unboxing, we can perform different types of numeric objects in expression. Let's see how it happens. First, we have taken integer I as 35. Then we have taken double D as 33.3. Then you can see one was integer, one was double. Now if I want to add this integer and double, D equal to D plus DA, that is auto unboxing which you are doing. First we are unboxing the value, then you are performing the addition and just addition, again auto boxing it back again. So once it unboxed, you unbox it, you perform the operation, then again you auto box, then you print the value, that is value of D is D. Now this particular value will be 68.3. You already have 35 and you have 33.3. The value will get added, that is 68.3. okay, value of D is 63.3. Now error prevention with autoboxing and unboxing. Autoboxing and unboxing will also help to prevent errors that occur with the manual boxing and unboxing. We have already discussed before. Now let's see how. Integer IOB, what we have done is we have autoboxed the value of 1000. Next, what we are doing is we are trying to manually unbox it as byte. Okay, if you try to manually unbox it as byte and you try to print the value, it does not print the value as 1000. Okay, that means sometimes you get errors while you try to do manual boxing and unboxing. That's why it's better to avoid manual boxing unboxing and shift to the auto boxing and all. Okay, the value of 1000 is manually unboxed using the byte value, causing truncation and resulting an incorrect value of -24. That means this value is incorrect. This is wrong actually. Next, we have something known as annotations, metadata in Java. What they will do, annotations in Java provide a way to add metadata to your code, allowing tools, debuggers, and application to understand and utilize this information. This metadata can help in analyzing, documenting, and controlling the behavior of the code. So metadata, I guess you have studied in your previous semester DBMS also. What it will do is this metadata will help you to analyze, document, and control the proper behavior of the code. It's nothing but information you are giving, which is needed on the behalf of this from the you can say from the programmer side to analyze the code and to have a proper information about the code. That's why you give a metadata information. Moving forward, so let's deal with the definition first. Annotation is a form of metadata that can be applied to the various elements of Java source code, including classes, methods, variables, and parameters. What is the purpose behind it? To add additional information to the code, which can be... Okay, so what is the purpose of my annotation? Annotation is used to add additional information to the code, which can be utilized by tools and frameworks during the compilation or runtime. Next, we have is compilation and reflection, like how it is using. Annotations are compiled into bytecode and can be accessed using reflection. This allows the program to query the metadata information and perform the actions accordingly. That means you're already having the metadata, you already have the information also. Like if I consider one series of execution is going on, if I give a metadata info, like first addition, then subtraction, then multiplication and division, you are already giving the information prior only, like how the series of events is going to occur. That's all about this compilation and reflection. Now let's understand this metadata first. Now it is declared using the keyword of final. Remember, final public final class, my final class. Now what is this metadata? The final keyword in the class declaration is a metadata indicator. Okay, this final is nothing but a indicator for metadata. Then purpose, it tells the compiler and the JVM that this class cannot be subclassed. Okay, now next we have metadata in Java context. What is in Java context? Metadata provides additional information about the code as discussed earlier, helping the JVM and the developers to understand and use the code much more efficiently. For using that, we use the final keyword in public final class, adds a flag indicating that the class is final. We are just adding a flag value that yes, the class is final. Next, we have is the built-in annotations in Java. Built-in annotations, what it will do is it will convey the metadata about the code, which can be utilized by the compiler and the runtime environment. The annotations help in various aspects such as code documentation, compiler warnings, and specifying how custom annotations should be used. So built-in annotations, what will do is it will mainly convey the metadata about the code. That means we can it will help me to to document the code, and also errors, not the errors, warnings which generated by the compiler, and also how it can be utilized by the compiler as well as in the runtime environment. So just let's see what is present. First is override. Override, what will do is it ensures that a method in a subclass is overriding a method in its superclass. If not, it results in a compile time error. That means in override function, we have a method, and in a subclass, it's overriding one more method in its superclass. So if it's not present, then it's a compile time error. At the rate override, guys, this is a sign you have to remember, at the rate of override. Okay, for built-in annotations. We see we have a class called animal. This is nothing but the, you can say the base, not the base. This is the, you can say the child class. Okay. No, not child class. It's the parent class only. Okay. Void eat something, eating something. Then we have a class dog, which is extending animal. That means we have implemented inheritance here. That means all the from animal class, we're inheriting some of the other properties in this dog class. Again, what we are doing is overriding. We are doing that means inside one more method, eating foods. Then again, we have a main function. In the main function, animal a equal to new dog, a dot eat something. So what it will output? Eating foods. Okay. Next, we have something on a suppress warning. Suppress warnings are generally suppresses specified compiler warnings useful for ignoring warnings about deprecated APIs or for unchecked operations. Nothing but you are trying to suppress some kind of the compiler warnings. It is also useful for ignoring warnings that are generated by some deprecated APIs or for some unchecked operations. Okay, so here is the code for that. Suppress warnings @ suppress warnings unchecked. We have taken an array list. In array list, what we are doing is we're adding some of the other elements. First we add is a, followed by that we have a, b and c. Then just system.out.println object, it will do nothing but some errors, not errors, I would say some warnings will be generated, and that will be ignored by the compiler, and then it will output as a, b, c. Okay. Next we have is deprecated. Deprecated, what it will do is it will mark some method or class to be deprecated, meaning it is no longer recommended for use and may be removed in the future versions. That means deprecated will be used whenever the particular class or a method is of no use now, and it can be removed in the further future versions as well. For example, first we have seen a method we have declared void m system.out.println hello, then deprecated. That means here we have declared one method or class which that means it is no longer recommended to use and it has to be removed further. Okay, next we have is then we are just calling this main function. This calling a main function a dot a is equal to new a dot n. What is present in n? Hello n. So it will print as hello n. Okay, so let's start built-in annotations for the annotation. So first we have something known as retention. What is this retention? Let's see. Retention, what it will do is it specify how the annotation should be stored and accessed. It can be retained at runtime, compile time, or only in the source code. So what is this retention? Retention basically defines how long your annotations are retained, and how it can be used. Right, can retained like in runtime, compile time, or only other in the source code. So let's analyze this example. What happening is import java.lang.annotation retention. Then we have a retention policy. So retention policy is nothing but the annotation is available at runtime, only, and the annotation is recorded in the you can say in the class file, but it's not available at runtime. Okay, and the annotation is discarded by the compiler and is not included in the class file. So this is the code for that, retention.runtime. Then we then public @interface my custom annotation. Then we apply retention policy. So what it is doing is basically I will say that annotation is available only at the runtime only, at runtime via reflection, and the annotation is recorded in the class file, but it's not available at the runtime. It's only available in the class file only. Next we have known as documented. Documented, what it will do is it indicates that the annotation should be included in the Javadoc for the annotated element, making it a part of the documentation. Okay, so let's look into the code. This is the code for the java.lang.annotate.documented. Then we are @ documented. Then again we're creating an interface for that. That means it indicates that annotation should be included in the Javadoc generated for the annotated element, and also a proper you can say it is mainly used for making a part of generated documentation. Next we have is target. Target mainly specifies the types of elements of an annotation that can be applied to. Also how we can apply, we have an element type, element type.type, and element type.method. Okay, so element type.type, what it will do is, that means element type, what it will take all the class, interface, and enum. And element type.method, what it will do is it will take all the methods. Okay, so this is the code of this target method. So these annotation mainly help control how your custom annotations are used and are documented inside your Java code. Okay, let's move forward. Next we have is inherited. The inherited, what we'll do is the inherited annotation in Java will allow all the subclasses to inherit annotation from their parent class. Is it visible? Yeah. Okay, so inherited, what it will do is inherit annotation in Java mainly allows subclasses to inherit annotation from their parent class. So let's see how it works. Like what happens is, like when we like if you look at this code, import java.lang.annotation inherited, we are performing this inheritance operation. We are applying some source code. Then we have a custom annotation. Then child my class extends my parent class. So what happens is, like when applied to a class level annotation, it indicates that the when applied to a class level annotation, it indicates that the annotation will be inherited by subclasses. Okay, so this is particularly useful for class level metadata that should be applied to derived classes as well. So this is the summary. You can see this is a summary of the entire code. Like at that override, what we'll do is it ensures a method is overriding a method from its superclass. Then we have suppress warning. Suppress warning, what it will do, it will suppress like specific compiler warnings like unused variables and all. Then we have deprecated. Like what it will do is it will mark the elements as outdated. That means it is not safe also and not used for its future versions as well. Okay, now annotations which are applied for other annotations, like first we have retention. Retention, what we'll do is it defines the duration for which my particular annotation is available. Next we have is documented. Documented marks that the annotation should be included in the Javadoc documentation format. Next we have is the Java target. The target specifies the valid target type that is the annotation should have, and then is inherited. Inherited allows the inheritance of the different subclasses. Okay, let's move forward. Next we have is the custom user annotation. Custom user annotation, what this is, it will allow you to create your own metadata to annotate class methods, fields or elements of your code. This can be particularly useful for code analysis, documentation, even runtime behavior. So custom annotation, what it will do is we are giving our own metadata to annotate the classes, methods as well as other elements we are giving in our code, which is basically it will be used for our code analysis, documentation as well as runtime behavior. Next is how will you create custom annotations. First step is you define the annotation itself. For that we use the keyword @interface to declare a custom annotation. Very much important guys, @interface. It is used to declare a custom annotation. Next we have is annotation elements. The annotation elements, what will do is it will define the methods within the annotation to specify elements, and these methods what it will do is it will act as attributes or acts as element of the annotation type, and they must not have parameters or throw any clause. That means it will have some parameters of the elements inside them, but it should not throw any clause. Okay, now what is the return type? Return type is the return type for the annotations are limited to primitives, string, class, enums, other annotations and arrays of above types. Default values, you can provide default values for other annotation elements also. Okay, next we have is types of annotation. First is the marker annotation. Marker annotation, what it will do is an annotation which is not having any methods. Okay, and it is used to mark a specific element itself. So let's look at this example, @interface my marker annotation. This is the example. Next we have a single value annotation. Single value annotation, what it will do is it will take a single method which is usually used to specify only one value. Okay, now this is the code for that. @interface my single value annotation, int value default of 0. Next we have is a multi-value annotation or a full annotation. What it will do is like an annotation with more than one method. Okay, and it is basically used for defining or dealing with more complex attributes. Okay, that is all about multi-valued, which has more than one method and dealing with more complex attributes. This is the code for that. Int value 1 is default 1, then string value 2 default, then string value 3, and this is the code for multi-valued annotation. Fine guys, now next we have is this one, how this example code of custom annotation. Let's look into this code once. So what we have done is here, first we have defined the annotation. Okay, and what we have defined the annotation, we have used @retention, retention policy, target, as well as documented. to specify the retention policy, target element, and the documentation methods. Okay. Next, we apply the annotation. For applying the annotation, we annotate methods or other elements with your custom with the custom annotation. Like you can see, like class hello is there. You have applied the annotation. Here you can say you define the annotation. In this section, you apply them. Okay. Next, once you apply it, then you're retrieving the value of the annotation. Like once it's done, you retrieve, that is what value we want to retrieve. Okay, like first we have done a try catch block. So in try catch, what we are doing is we are creating an object of hello, a hello of h. Okay, and we get the class object representing the class. Then we have a method object for representing the method. You have a get annotation from the method as well. Now we are just printing the values which is present in value and name. Okay, now next, if it has an exception, it will throw like some unexpected thing has occurred, and therefore it has come under exception block, and therefore that means this encounters the error block actually. Okay, now next we have is the you can say the retention, the restrictions on annotation. So restrictions, what it is like, first is no inheritance. No inheritance in the sense annotations will not inherit from other annotation. They can only extend the java.lang annotation interface. Okay, this you have to remember, like it cannot inherit from other annotation, but it can extend the java.lang annotation.annotate interface. Okay, I'll just write this name, java.lang annotation interface. Fine guys. So next we have the method constraint. Method constraints, like methods in the annotation must not have any parameters, because annotations doesn't support any kind of arguments. Also, it should not have any kind of throw clause. Like annotation methods should not throw any exceptions, and also return type should be of primitive types, like for example int and double. Also object of string or class, or a enum data type. Or it can be another annotation type also, or it is an array of preceding types. So that's all about this module 1. Coming back from this beginning, if we see, we have covered the enumerations, autoboxing, annotations. Okay, various code snippets we have seen, retention policy, deprecated warnings, compilers and all. So the notes and all, everything will be shared in the Google Drive. You can go and access the study materials from there. The notes are prepared from your textbook itself, which is prescribed under VTU. Okay, so yes, if you have any doubts or anything, please let me know in the comment section. Module wise important questions along with the previous year questions, question bank will be uploaded very soon. So please stay alert in the YouTube channel. Till then, like, share and subscribe. Thank you guys.